boys and girls. Mrs. Plummery here, the science lady. Today we are in day 4 of the unit Sunny Days. I can investigate how the sun can be helpful and harmful. Today what we're going to need is some construction paper. A dark color works best. Some sunscreen. Okay, and the first thing we're going to do is we're going to fold the piece of paper in a third. So not quite half, but about a third. And I'm going to put a crease in it, like this. Okay, and on this side of the construction paper, I'm going to make a design with sunscreen. Now you can make anything you want. You can do circles or hearts or butterflies. Okay, I did some hearts. Okay, here we go. You want to use a lot of sunscreen. And what we're going to do with this paper is we're going to put it outside in a sunny location for about 2 or 3 hours. Let me give you a little tip. Put a rock or something heavy on it so it doesn't blow away. And while you're waiting, you are going to make a prediction in your science notebook. What do you think this paper is going to look like after 2 or 3 hours in the sun? Okay, boys and girls, I'm going to go outside and put my paper in a sunny location. See you next time.
Hi scientists, Miss Staley here, ready to dive into our next exploration in the soil formation lab. In this lab, we have been learning about what soil is made of, and different types of soil. Now, there are lots of different types of investigations. Today, we will be conducting a field study. It's easy to remember what a field study is because it's when a scientist like you or me go outside, or what scientists call the field. The field can be anywhere that's not inside your classroom or the science lab. So when we conduct a field study, we will be making observations. Do you remember what observations are? Scientists make observations by looking carefully at things. When we conduct a field study, we will be observing both living and non-living things. Back in first grade, you learned about living and non-living things. Can you tell me, is soil living or non-living? I'm not going to tell you the answer to that question just yet. As we work through this lab, you will discover whether or not your answer to that question is correct or incorrect. You'll also be able to give evidence to support whether or not your answer is correct and whether or not soil is a living or non-living thing. So let's get ready to gather our soil sample. When scientists collect a sample, it means that they are only collecting a small part of whatever it is that they are investigating. Can you imagine what might happen if I tried to collect all of the soil that was outside? It would disrupt all of the organisms or living things that were in that environment. Plus, it would be really hard to carry all of that soil back here to the classroom. So instead of doing that, I'm just going to collect a sample or just a small amount of soil. To do this, we're going to need the following materials. I've got a bucket and a beaker to collect my soil sample. If you don't have those materials, you can collect your soil in a cup. When I get back to the lab, I'm going to need a paper plate and forceps. Forceps are used by scientists so they can explore things without having to touch them. If you don't have forceps, you can also just use a pencil to poke around in your soil sample so you can make observations and see what is in there. I also am wearing my hand lens. Can you remember what scientists use hand lenses for? One last thing before we go outside to collect our soil sample. Remember, anytime that scientists go out into the field, we must remember to be respectful of nature. If we come in contact with any organisms or living things, we will treat them with kindness and leave them alone. We also need to be very careful when we are collecting our samples. I'm going to try to stay away from very bushy areas where an organism may be hiding. Humans can be pretty scary to smaller organisms, and if I scare an organism that I come in contact with, it may try to defend or protect itself. So now that we have all of our materials ready and we know what to do to stay safe as we go out into the field, Let's head out there and collect our soil sample. All right, scientists, so as you can see, we're outside ready to collect our soil sample. Got my beaker and my bucket, so let's do it. All right, and I'm gonna get 2 scoops just because. All right, let's go back inside and see what we got. So we're back in the classroom and I want to share my soil sample with you. But how am I going to do that? I know some of you are learning at school and some of you are learning remotely. The way that I'm going to share my soil sample with you is to use a document camera. And this is actually something that your teacher can do as well. If your teacher collects a sample of soil, he or she can share the soil sample with both the scholars who are learning at home and those who are learning at school. Pretty cool, huh? So let's go ahead and take a look at the soil sample that I collected. Alrighty, so here we go. As you can see, I've got my bucket here with my soil sample and my paper plate and my forceps ready to go. Is there anything that you observe just right off the bat? I know that there are a couple of things that kind of stick out to me. I wonder if you notice them too. So to help you see a little bit better, I am going to zoom the document camera in so we can take a really close look at the soil sample. So what I want you to do now is I want you to explore your own soil samples, whether you are at school or you are at home. And I want you to observe whether or not you find some of the same things that I found in my soil sample. I predict that you are going to find some different things in your soil sample. Can you guess why I am making that prediction? Think about that and we will talk about it next time I see you. Take care.
Hey Jack, are you ready to do some science with me? Okay, let's go. Hey scientists, welcome to my backyard. Here is our stream table that we are going to build. So this is a stream table. I have my stream table on the first level of the stage, and I've made sure that the plug is closed. So the first thing I'm going to do is pour in some water. I have 500 milliliters of water, which is approximately 2 cups of water. I'm going to pour that in the bottom end of it. Okay. And then I'm going to make a little island with some sand. I just have some sand that I had left over from actually a sandbag during hurricane season last year. I'm going to use some of that. You could use sand, dirt. I'm going to make it about halfway down. It's going to be a long, thin island. And a little bit more. So this is a fancy stream table. That's all you need. But let me show you how you can make one at home. Here I have that aluminum pan I showed you earlier, and I just found a scrap of wood because I do need it up on an angle. So I'm gonna do exactly the same thing. I'm gonna pour in 500 milliliters of water. Okay. Carefully pour that in at the bottom. Depending on the pan size, you may want a little less. I'm going to take sand, like I did before, make my island. For my home version, I probably should have used a little less water, but that's okay. But add rocks, add dirt, and there you go. These are the 2 versions of our stream table that I've made. Alrighty, so we have our 2 stream tables set up. Now I want to focus on the role that wind plays in weathering and erosion. So first we need to create some type of wind. So you could use a blow dryer. I found a dustpan. You could use another type of fan, but I have something even more fun for today. This calls for my safety goggles. Are you ready? My leaf blower. Before I turn it on, how do you think our strong wind will affect our 2 islands? I wonder. Well, let's try it out. Here we go. What did you see happen? Look closely. Both of my islands have totally changed their shape and made a mess in the meantime. Interesting. How do you think and where do you think this would occur in nature?
Mr. Height here, your favorite scientist. And whoa, don't worry, I'm not in the river. I'm standing on a rock. So I'm not in the river. So I'm safe. I'm okay. But yeah, pretty cool behind me. Hey, we're talking about resources. So what kind of natural resources do you see behind me? Can you identify any natural resources? And can we use any of these resources for energy, things that we might use as energy sources or other types of sources? So take a minute and think about what's behind me and what kind of resources those items appear to be. Cool. So actually today I'm going to give you a little tutorial on our build a city model. It's a virtual lab, which is kind of cool. You'll be able to build like a city and using some different resources, you can see how to power that city. And if the way you build it, is it going to generate enough energy for the city to use? And you'll see what types of resources are we using? Are we using renewable or non-renewable? So that'll be our good question. So I'm going to go ahead and share my screen. So I'll bring up the site. Here it is, our resources on Earth site. Very good. And one thing to make sure you do first is there's on the side here, what are the advantages of alternative energy sources? That's some really good content building. So make sure you read through this piece here, this text, lots of good things about renewable, non-renewable resources. So really good things. You can jot some notes down, some important notes to help you remember and have a discussion. There's also some vocabulary as well that you can note. And then there is a procedure right here for this virtual lab. But I'm going to go ahead and actually run through it so you can actually see it and see how to do it. Again, you should have your science notebook out to take notes and things like that. Also, you should have a recording sheet for your cities that you build and test out. And that might be through a Nearpod, or your teacher might have given you a page to put in your science notebook, or you could make the table in your science notebook. But here we go. So one thing you definitely want to do before you start building your city, go ahead and when you go to the reference tool, you'll see the different types of energy. I would definitely read through these first and a little bit more understanding of the types of energy that you could use to power your city. I would definitely do the first four. I wouldn't really mess with biomass. That's not one we're really going to go into. I would definitely just focus on solar, wind, hydroelectric, and geothermal. And you can go back to those at any time while you're doing this virtual lab. So that piece is there for you. And you can see the different components. Here's the meters down here, which are very important because these meters will tell us how did we do when we built our city. So the first one is expense, like money. So we want to make sure our energy source, whatever we're using, doesn't cost a lot. So it's not costing the people that live in the city a lot of money. At the same time, we want to make sure our energy output is very high. So we want to make sure the city is able to get enough power using our resource. So we want to keep our expense low and our energy output as high as possible. That will help you. So I hope you enjoy this virtual lab. It's really cool because this is something that's very big. This is a big concept. And the cool thing is we can study something on a huge scale in a simulator or a model just like this. So we can do some studying and observations of something that's very big, but bring it down to a small scale. And that's what scientists do when they study things like this, or space, or something else that's very big. They use models and simulators all the time. So I hope you enjoy your simulator and really think about how can we get the most energy to our people in the city here without them spending too much money. All right, guys. So I share my screen. This is Mr. Height here, and I'm still in the river. I might go kayaking for a little bit. So I'll see you next time.
Hi, second graders. This is Miss McClure, and I'm outside in my backyard today to teach you a little bit about how to read a rain gauge and how to read a thermometer. You're going to be doing an investigation where we are looking at weather patterns over a week. And as we look at these weather patterns, we're going to read the temperature and we're going to find out how much rainfall there is each and every day. Now, I've created my own little weather station here in my backyard. And as you can see, there is a thermometer and there's the rain gauge. Now, notice right now we don't really have a lot of rain in the rain gauge. And the temperature, it basically says that it is about 100 right now. So it's very hot outside. And even this thermometer is in the shade. We want to make sure that we put our rain gauge and our thermometer in a place where it's not going to get overheated and the top part of the rain gauge is not blocked so that the rain can go into the rain gauge. You want to make sure each day you dump out the water after you read it so you can get an accurate measurement and it's not the water from the day before or the rainfall from the day before. And each day when you come out, you want to make sure you read the temperature and read the rain gauge at the same time. So that way you get some accurate measurements. You're going to get a chart, and up at the top it's going to have some thermometers. Each day you want to make sure that you're putting the correct temperature on the correct day. Remember, we're going to read in Fahrenheit instead of Celsius because we live in the United States. Also, you're going to read the rain gauge at the bottom level of where the water stops. So you want to make sure that you are reading that in inches or in milliliters, depending on what type of rain gauge you have. Now, I've put some directions in there on how to make a rain gauge as well. The last thing you're going to do is you're going to look at the weather conditions. So if you can see behind me, there are some dark clouds. There are some puffy white clouds. Those clouds are starting to build up and get a little gray. So that means that we might have some precipitation or some rainfall that's coming our way. So you can see some big gray clouds behind that. So I might want to say it's cloudy, but it's also very hot right now. So I could also say that it's sunny. Over on this side of my backyard, if you look over in this area, you're going to see that the clouds are not as gray, but they're starting to build up and there's some blue sky. So I might want to talk about the difference between the different areas to see what different locations or weather might be happening in my area. I might not just put it's cloudy, but it's also a little sunny. So every day you're going to go out and you're going to read your rain gauge, and you're going to read your thermometer, and then at the end of the week we're going to look at any weather patterns that we notice. Changes over time. Is it always rainy? Is it always sunny? Is it sometimes cloudy? What are the things that we're noticing? Now, since it's summertime, we're going to notice that there are going to be some really hot temperatures. I'm out here sweating right now. And we're also going to notice that there are going to be some days of rain and some days that it's dry, depending on how many thunderstorms that we have. At the end of the week, let's think about what weather patterns we noticed. I hope you enjoy this investigations and become a local meteorologist. Remember, you can use websites or you can watch local TV stations to see if there is anything out there that helps you predict what kind of weather conditions we're going to have. You can watch my husband on Bay News 9. Watch Brian McClure at night starting at 7 o'clock to get your local weather forecast.